My name is Hasrian Juzman and my ID number is 20030038. And of course, I'm not alone to complete this project. Let me introduce to all of you my best partner. And the first one is...
My name is Muhammad Fadil and my ID number is 20030041.
My name is Rifqi Zahran with 20030092 student ID number.
Hi, my name is Rizma Fadil Ulfah with 20030093 is my student ID number.
Hello, my name is Farhan Maulana Putra with ID student 200300795.
Okay, I will explain about my part. Point A, definition of Stokes theorem. According to James Stewart, 1998, suppose S is a surface bounded by a closed and simple border curve C with a positive orientation, and F is a vector field whose components have continuous partial derivative in open regions containing S. Then, R cubed is integral C FdR equals double integral S curl FdS, because integral C FdR equals integral C ftds, and double integral S curl FdS equals double integral S curl fnds. Stokes theorem states that the line integral around the boundary curve S of the component of tangent f is equal to the surface integral of the normal component of the chord f. The positively oriented fortune curve of the torus S curve is usually written, so that Stokes theorem can be expressed as dou S. Double integral dou S curl fds equal integral dou S fdr. There are analogies between Stokes theorem, Green theorems, and fundamental theorems of calculus. Like the equation above, there is an integral involving the derivative of f. The curl f is a kind of derivative of f, and the right-hand side involves the value of f on the S boundary. In this special case, where the surface S is flat and lies in a plane with an upward orientation, the unit normal vector is key. The surface integral becomes a double integral, and Stokes theorem becomes integral C fdr equals double integral S curl fds equal double integral S curl f key ds.
Next to point B, special case proof of Stokes theorem. Suppose the equation S is Z equals to gx, y when x, y element of D, with G having continuous second order partial derivative and D is the simple plane whose boundary curve relate to C. If the orientation of S is upward, then the positive orientation of C corresponds to the positive orientation of C1. We are provide F equals to Pi plus Qj plus Rk with the partial derivative of continuous P, Q, and R. Since S is a graph of a function, the formula can be applied. Integral lipat 2S dari curl f ds sama dengan integral lipat 2D dikalikan dengan minus dalam kurung dou f per dou y dikurang dou q per dou z dikalikan dengan dou z per dou x dikurangkan dengan dou p per dou z dikurang dou f per dou x dikalikan dou z per dou y dan ditambahkan dengan dou q per dou x dikurang dou p per dou y dA. With the partial derivative of p, q, and r, calculate at x, y, gx, y. If x equals to xt, y equals to yt, di mana t nya besar sama dari a, kecil sama dari b, is the parametric representation for then the parametric equation for C is C1, X equals to XT, Y equals to YT, Z equals to GX, Y, dimana T bersama dari A, kerjasama dari B.
Okay, with the help of the chain rule, the line integral can be calculated as follows. Integral C if dr equal integral A until B, P dot x dot t plus Q dot y dot t plus R dot z dot t in parenthesis dot t equal integral A until B, P dot x dot t plus Q dot y dot t plus R dot z dot x dot t plus dot z dot y dot t in parenthesis dot t equal integral A until B, P dot x dot t plus R dot z dot x in parenthesis dot x dot t plus T plus R dot z dot y in parenthesis dot y dot t in parenthesis dot t equal integral C1 P plus R dot z dot x in parenthesis dot x plus T plus R dot z dot y in parenthesis dot y equal double integral D dot per dot x in parenthesis Q plus R dot z dot x minus dot per dot y in parenthesis Q plus R dot z dot y in parenthesis dA. Keeping in mind that P, Q, and R are function x, y, and z, and that z itself is a function of x, and obtain integral C f dr equal double integral D in parenthesis dot Q dot x plus dot Q dot z dot x plus dot R dot x dot z dot y plus dot R dot z dot x dot z dot y plus R dot square z dot y dot x minus in parenthesis dot p dot y plus dot p dot z dot y plus dot R dot y dot z dot x plus dot R dot z dot y dot z dot x plus R dot square z dot y dot x in parenthesis dA.
C. Sample problem and their solution. Now vector field f x y z sama dengan 3 y dikurang x z j ditambah yz kuadrat k, and see the paraboloidal surface bound by the pad C is the circumference. Use Stokes theorem to calculate 2z sama dengan x kuadrat ditambah y kuadrat z sama dengan 2 integral lipat 2s curve f n dA. Kita misalkan si track x kuadrat ditambah y kuadrat sama dengan 4, z sama dengan 2 atau x sama dengan cos t, y sama dengan 2 sin t, z sama dengan 2 dengan t besar sama dari 0 kecil sama dari 2v. Nah, lanjut, integral lipat 2s curve f n dA sama dengan integral c f dr sama dengan integral c 3y dx dikurang xz dy ditambah yz kuadrat dz. Nah, menjadi integral c sampai 2v 3 kali 2 sin t dikurang 2 cos t 2 ditambah 2 sin t 2 kuadrat dt, menjadi integral dari c sampai 2v 6 sin t dikurang 4 cos t ditambah 8 sin t dt sama dengan min 6 sin t dikurang 4 cos t dikurang 8 sin t sama dengan 0.
Stokes' theorem states that if a ball moves in a fluid which is stationary, a frictional force will work against the ball in the form of a frictional force whose direction is opposite to the direction of the ball's motion. The conditions for the application of Stokes' theorem are: 1. Space where the fluid is limited. 2. There is no turbulence in the fluid. 3. The speed is not large, so that the flow is still linear. Stokes' theorem in everyday life is applied in several ways, including: 1. Engine lubricants that we usually know by the name of oil. 2. The law of blood in the veins. 3. Process of frying fish. The higher the temperature, the lower the viscosity of the cooking oil. 4. The flow of water in PDAM pumps that flow to our homes.